Alright, ladies and gentlemen, this is the time of the hour. This is pre-calculus. We are talking about trigonometric ratios and right triangles. And we're going to talk about the big boys: sine, cosine, tangent, cosecant, secant, and cotangent. Now, you've seen these a ton in Algebra 2 from your past career. You talked about the graphing and stuff. Now we're just going to do a refresher course. Okay? Now, sine is usually written as sin. And if you want the code to do theta, it is Alt 233, and sine of theta is equal to the opposite side of a triangle divided by the hypotenuse side. Okay. Alright, and in this case we'll be talking about this type of triangle. And we're just talking about right triangles to begin with, right acute triangles. Okay, so first off, that's a right angle. Let's make this theta right here. So that makes this side opposite. Now obviously whatever perspective you're looking at changes where theta is, and it also changes where the opposite side and the adjacent side are as well. Okay. Alright, now cosine of theta is going to be the adjacent side of a triangle, the adjacent side to theta, divided by the hypotenuse. Okay, and tangent of theta is going to be equal to the opposite side divided by the adjacent side to the theta angle. Okay, now sine and cosine, we'll talk about that relationship a little bit later. Now the cool thing is that cosecant, which is spelled like this, pretty easy, CSE, is just going to be the reciprocal of sine, so it's going to be the hypotenuse divided by the opposite side. Okay, and secant is going to be spelled SEC. For those of you that are college football fans, that's going to be gorgeous. Little acronym right there. So hypotenuse divided by the adjacent side, and cotangent is just cot 233 equals the adjacent side divided by the opposite side. Okay. Alright, now here's some codes that help you out in trig, or especially in pre-calculus. These are called alt codes, and this is for office. Well, just be careful about which office you use, okay? But basically, theta is this first one, so we'll call this theta. Okay, the second one is alpha. This next one is beta, and that's uppercase right there. This is the degree sign. And this is the plus or minus sign. Okay? Alright, so as long as you keep these ones in check, you should always be able to type into your answers these type of work, okay? Okay, so what we're going to do from here on out is we're going to fill out a table of values and everything. Okay, and as you kind of briefly saw when I came back, when just a quick glance of what it's going to look like. Another way to really kind of recognize the facts of how this works is to just look at the first letters of each part, and it's like a mnemonic device. So sine, opposite divided by hypotenuse, cosine is adjacent divided by hypotenuse, and tangent is opposite divided by adjacent, and that gives rise to the saying so ka toa. Okay, and so that just helps us remember our mnemonic device of like, okay, which one goes where does opposite go, where does adjacent go, all that stuff. Okay, alright, so let's take, without further ado, oh, I always forget to give you guys history. History of trig is actually from the idea of the study of similar triangles. And because of the study of similar triangles, they found out that some relationships exist with certain angles and sides. And that's what gave rise to looking at special right triangles. These are just special triangles. You guys all know these as the 45-45-90 triangle and the 30-60-90 triangle from trig. I'm sorry, from geometry. and stuff. And so no matter what size this is, this relationship always works out, and that's why I put the y's in here and the x's in here, because the relationships always seem to stay the same. So this is really kind of cool. So first off, we're going to look at sine, and then we're going to replace theta with these angle measurements, and then write the ratio side that we're dealing with. Okay, so sine of 30, we identify 30, so the key is you always identify the side you're working with. So we're looking at 30 here. Okay, so sine is going to be opposite over adjacent, so it's going to be x over root 3, which simplifies to 1 divided by root 3, okay, which turns into, I just made a mistake. I made the mistake as usual. Okay, it's going to be opposite over hypotenuse. So it's going to be x over 2x, which just simplifies to 1/2. Whew. I just caught myself there on that one. Okay, all right. Now cosine is going to be adjacent over hypotenuse. So cosine is going to be the adjacent side to 30. Okay. Well, let's not take a look at that. Let's look at this. Yeah, let's do this. Let's just finish 30. Okay, so it's going to be x root 3 over 2x, which the x's cancel out, so I'm left with root 3 divided by 2. Okay, now the 3 is going to be in the only one being square rooted, so just so you understand, it's not the square root of 3/2, it's the square root of 3 divided by 2. Okay, now tangent is going to be the one I just did, so it's going to be 1 over root 3, okay, which amazingly enough turns into root 3 divided by 3. Okay, and that one's going to be kind of squished in here. I'm sorry about that. Here, watch. We'll move this one over. There we go. Alright, and then the cosecant, secant, and cotangent are just going to be the reciprocals of that. So cosecant is going to be 2 over 1, which is 2. This is going to actually turn into 2 root 3 divided by 3. Okay, and just remember the root is around the 3, nothing else. Okay, and then cotangent is just going to be root 3. Alright, so that one's pretty simple. Alright, now what we're going to do is we're going to change our focus from around the 30 to the 45. Now if you know, no matter which one I put it on, it's going to be the same. Okay? Alright, so I'm going to use SOHCAHTOA again for it. So sine, I'm going to really pay attention, it's going to be y over y root 2, which simplifies into 1 divided by root 2, which turns into, when I rationalize it, it's going to be root 2 divided by 2. Okay, and that it's obviously going to be root 2 up there. All right, now if I do cosine, it's going to be the same exact thing. So it's going to be root 2 divided by 2. Okay, tangent is going to be y divided by y, which turns into 1 divided by 1. Which turns into 1. That one's pretty simple. And then cosecant is just going to be the reciprocal of sine. So it's just going to be root 2 in the beginning. Same thing with secant. Okay, and cotangent is just going to be the flip version of tangent, so that just turns into 1. So those ones are pretty easy. Okay, now what I'm going to do is I'm going to shift my focus from the 45 to the 60 and just work across that way. Okay, so this is going to be opposite, so x root 3 over 2x. Well, isn't that a lot like that one? I mean, because I just remember just doing that. So let's just go ahead and simplify it as is. So alt 251 square root of 3 divided by 2. Okay, now adjacent divided by hypotenuse is going to be x over 2x, so that just turns into 1/2. That's interesting. That looks like that sign up there. And tangent is going to be x root 3 over x, so that just turns into root 3. which is really interesting because that looks like that one up there, and that's the exact calculation I did. Okay, so this one is going to turn into 2 root 3 over 3, and just remember the oops, boom. Just remember that's how it goes. That's interesting because that looks like secant. Cosecant of 60 is like secant of 30. That's interesting. And if I flip this one, I'm going to get 2, which means that secant of 60 is going to look a lot like cosecant of 30. That's interesting. And then cotangent, well, if I just flip this one, it's going to look like this one up here. So it's going to be the alt 251 divided by 3. Okay, now here's some cool patterns. Okay, this looks like this. Okay, and this looks like this. And honestly, these two look alike. Okay, so what that means is sine is a co-function with cosine. That's a really cool fact. Okay. Oops. Let's go to a different color. Now that also means cosecant and secant have some co-function relationships because they fall, since they're reciprocals, they also follow the same kind of relationships. So cosecant is a co-function with secant. Okay, so that's some really cool stuff right there. Alright, let's go to purple. Now tangent, if you notice, follows some similar patterns with cotangent, and these two are going to be equal. So tangent is a co-function with cotangent. Okay. Now, what a cofunction means is that it's almost like the complement of the other one. So, for example, sine of 30 degrees is going to be equal to cosine of 90 minus 30, which is equal to the cosine of 60. And that's what cofunction is. And if you notice, the sine of 30 is the same as cosine of 60, which makes sense. So whenever you see cofunctions, they just line up with each other. And the two angles have to add up to 90 degrees. That's the amazing thing about cofunctions and how they work. All right? All right. If that's all, if you guys have any questions, feel free to contact me. But otherwise, this is the beginning of Trig.